Hello students, hi everyone. In this video I am going to explain you about this topic, reflection of light at curved surfaces. Okay, what is the topic? Reflection of light at curved surfaces. This is the first chapter of our syllabus. Okay, let us recall some knowledge what you have already studied in your lower classes. You have studied about reflection of light at plane surfaces, isn't it? So what is a reflection of light at plane surfaces? Before going to that topic, first let us discuss the basic knowledge of light. What is light, how it produced, and how does it travel? Okay, come, let's discuss about that. Light, first of all, light, the definition of light. What is light? Definition of light: light is a form of energy. Light is a form of energy that is produced from a self-illuminating body, isn't it? Light is a form of energy that produced from a self-illuminating body. Okay, it is a form of energy. There are many forms of energy in the universe, isn't it? What are the different forms? Sound energy, heat energy, okay, solar energy. This light is also a part of solar energy, isn't it? In this way, there are many different forms are there. Among the different forms, light is also a form, an important form. So it is a form of energy. Okay, from where does it produced? It produced from a self-illuminating body. Self-illuminating body means like sun. Sun is a self-illuminating body. It means the body which can produce the light on itself is known as a self-illuminating body. The other self-illuminating bodies are also what? Some tube light is a self-illuminating body. A candle is also self-illuminating body because they can produce the light on their own. The type of bodies are known as self-illuminating bodies. So this is the basic the definition of the light. Light is a form of energy. It produced from a self-illuminating body. Okay, that's over. Next, what are the different properties of light? First of all, what sensation the light produce? Light produces sensation of vision, isn't it? It produces sensation of vision. What is the meaning of sensation of vision? For example, if there is no light around us, what happens? The vision is not possible. It means you cannot see what are there around you. You cannot see any object around you. Okay, that is the sensation of vision. It means if light is there, you can see any object. That is called the sensation of vision. Light produces this sensation of vision, isn't it? Next, how does light travels? Light travels along straight path. Light always travels along straight paths only. Understand? It means, for example, here this is a source of light. See, source of light means like self-illuminating body. Okay, now the point from where the light produces, that is the source of light. Okay, now if it is a source of light, from here the light is produced, then what happened? The light will spread in all the direction, isn't it? It spreads in all the directions, but whatever the direction you take, in that direction light travels along straight path only. Okay, it doesn't travel like by bending and bending and bending. It just travels along the straight paths. Okay, this is the basic knowledge of the light. Understand? Light is a form of energy. It is produced from a self-illuminating body, and light produces sensation of vision. That means if there is no light, you cannot see any object. And next, light travels along straight paths only. This property is called what? Rectilinear property. This is called rectilinear property of light. Rectilinear property of light. It means light only travels along straight path. Understand? Yes. Now we shall discuss what is reflection. How does light reflect? You already studied about the reflection of light from plane surfaces, means plane mirrors. Plane mirrors. Okay. So let us just recall that knowledge also. For example, this is a plane mirror. Any plane surface. So let us take plane mirror only. Plane mirrors means a simple glass plate which is coated on one side. Here this is a plane mirror like this. The bottom side is coated. The bottom side is coated. The uncoated side, this top surface, behaves like a mirror, like a reflecting surface, isn't it? Now when light incident on this mirror, this is a light ray. Light ray must be represented like this arrow, a line with arrow. So the arrowhead indicates what? The light is traveling towards this direction. If I draw any light ray like this, the light is traveling in this direction. This light is traveling towards the mirror, isn't it? Yes. Okay. Now whenever light incident on this surface, immediately what happens? It gets reflect back. It gets reflect back. This is called the reflected light ray. It means the light ray which is moving, which is traveling towards the mirror is called incident light ray. This is called the incident light ray. And the light ray which is after falling, incident means what? Incident means the light ray which falls on the mirror is called incident. And after incident, what happened? It is again coming back on the same side. It is not going this side because there is coating on the another side. What is there? A coating is there. That's why the light ray is just again going back on the same side of the mirror. This light ray which is coming from the mirror, okay, this is called reflected light ray. This is the reflected light ray. Understand? So in this way, light incidents on the mirror, means on any plane surface or on any surface, whatever the surface may be. It need not to be plane surface only. Whatever the surface, it can also reflect from the curved surfaces. That is the topic we are going to discuss here. But first we are discussing what? How the light incident on the plane surface and gets reflect back. So this light ray after incident, what is coming back again from the surface is called the reflected light ray. Understand clearly? So this is the light ray which is falling on the mirror is called incident light ray, and the light ray which is coming back again from the mirror is called reflected light ray. Okay? So yes, here also we know how to measure the directions of incident light ray and reflected light ray. Directions means all the directions must be measured in the form of angles, isn't it? It means with which angle the light ray is incident on the surface and with which angle it is reflecting back. That we have to know. But how to measure the angles? To measure the angles, there is a method, isn't it? What is that method? This point is called, where the light incident, where the light falls on the mirror, this point is called point of incidence. Point of incidence. This point is called point of incidence. So at this point of incidence, we should draw a normal line. Normal means a perpendicular line. This line is perpendicular to this surface. Perpendicular to this surface. This is the most important thing. If you want to measure the angles of incidence or angle of reflection, we need to draw a normal to the surface. This is the most important thing. Okay, now why we should take like that, I will tell you later. First of all, you just see we have drawn what? A normal line, a normal to the surface. Now with reference to this normal, what angle this light ray subtends? See, this light ray makes an angle I with this normal line, whatever we have drawn, normal. Pn is the normal to the surface. With this normal, this incident light ray makes an angle I. Isn't it? It means the angle between the incident light ray and the normal is called angle of incidence. Next, the angle between the reflected light ray and the normal, same normal, is called R. R means angle of reflection. Here I in the sense angle of incidence, okay. And what is R? R is angle of reflection. Okay, angle of reflection. So to measure the directions, how the light ray incident and in which direction the light ray is reflecting back, if you want to know all these things, we need to measure the angle of incidence and angle of reflection. To measure the angle of incidence and angle of reflection, what is needed to do? A normal. Normal means a perpendicular line. Normal in the sense perpendicular line. Normal in the sense perpendicular to surface is called normal to that surface. First of all, we should draw a normal. Normal means a perpendicular line. Now we should measure what is the angle between the incident light ray and the normal. That is I. Always it should be represented by I. I means angle of incidence. And the angle between the reflected light ray and normal. Okay, that angle is called what? Angle of reflection. Isn't it? So now there is a law of reflection. What is that law? Law of reflection. This law of reflection is the first law. There are two laws. The first law of reflection, already you know about all these things, isn't it? The law of reflection, first law of reflection is this angle of incidence is equal to angle of reflection. Okay, no need of represent like this. I is equal to R. I is equal to R means always the angle of incidence must be equal to angle of reflection. On the regular surfaces means on the smooth surfaces. If you take some uneven surface, rough surface, the I may not be equal to R, but in most of the cases I is equal to R. So this is the first law of reflection. Understand? So this is the basic knowledge of what? Reflection of light from plane surface only. Now I will tell you that why we should take this normal. Okay, na? Why we can't directly measure this angle theta. For example, if you take a plane surface, on the plane surface, what you can do? If this is an incident light ray and this one is the reflected light ray, for the plane surfaces easily you can measure. Okay, na? This is I. For example, if you measure this angle I and this angle is R, it's okay. But if you take a curved surface like this, here the light ray incident and here the light ray is reflecting back. Okay, how can you measure now? Here this angle becomes I and this angle becomes R, but this is not a straight line, no? So it's not possible to measure the angles with reference to the surfaces on the curved surfaces. That's why we always take here, if you take a normal, what happens now? With reference to this normal line, the angle of incidence and angle of reflections are measured, not this angle. Okay, and here too, if you take a normal to this curved surface here, now this is the angle of incidence and this one is the angle of reflection, but this is not the method of showing. Always we should draw a normal line to the surface. Maybe it is a plane surface or it is a curved surface. It's very important to draw a normal line. Normal means a perpendicular line to that surface. With reference to this perpendicular line, with reference to this normal line only, we have to measure the both angle of incidence and angle of reflection. Okay, yes students, this is the basic knowledge of this topic, means reflection of light. But still we have not started actual topic, reflection of light at curved surface. This is the just basic knowledge. In the next video, I will explain you how the light reflects from the curved surfaces and what are the types of curved surfaces. Everything about that we will discuss in the next video. Okay na? Yes, okay. Bye-bye.